concept on the cognitive, it's the spectrum decision function. So this function should have kind of learning capability. So through the operation of the cognitive value, it should be gathered, for example, which band has low activity of the primary user, and keep this for the future decision, and so on. So the machine learning technologies will be an essential part of the cognitive value.
Do you have any method to evaluate the performances of the sensing method?
Can you repeat the question?
Do you have a method to evaluate the performances of the sensing method?
There's different sensing methods, and there's different. You have to implement that on physically or through the simulation devices. But in my study, I'm not focusing on the sensing method itself.
Yes.
I'm looking to the sensing method as a box, and there is input and output. The input is the information that we can have rather than sensing, and the output is the accuracy of the sensing. How much duration it's required, what's the probability of the detection, what's the probability of the false alarm. Based on that, I'm studying how to consider the cross-layer design. So this will affect which sensing method I will use. Did you get that? So my focus is not on the sensing method itself,
yes,
but I'm looking to the sensing methods as a box, as a function, and then based on the input and output of this function, how I can get the best out of it.
Do you have any other question?
I have a question about the values of parameters.
The what?
The value of parameters.
The parameters was the
Parameter and values.
Variance.
What's that?
Variance.
Values.
Variance.
Does mean how much frequent? Do you mean this one? This mean how much frequent it will be?
There are many parameters.
Yeah.
And I'm interested in how you can set the value parameter.
I want to get your question.
Value parameters.
Value.
Yes.
Value.
Values.
Value.
Value.
L-U-E.
Value.
Values.
Value of parameters.
The value of the parameter.
Yes. Yes.
Okay.
I think that the performance depends on my
Value.
Yeah, you mean the values. Now, for example, for the sensing duration, the energy detection one, which is the lower one, it can use 1 millisecond for the duration of the sensing. But if you go to the matched filter, it's come up to 20, 60, up to 400 milliseconds. It's based on, as I said, whenever you add the duration, whenever you have more duration, that means more samples of the signal, and then understand the signal or make the decision more accurately, more accurate than if you have less sensing duration. And then based on these values, what's the output that you can get? What's the probability of detection and the probability of false alarm? For example, within, let us say, 20 milliseconds of sensing, if I'm using the energy detection, I may get 60% of probability of detection. Within the same period, or sorry, the same duration, if I'm using the matched filter, I can reach